Go to TAPgiles.com to learn dreams, engage my services, and support the channel.
So we've got a calculator, and if you tweak it with L1 and square, it gives you the tweak menu. And it has an A, an operand 1, which is labelled A, and an operand 2, which is labelled B. Operand just means like one of the numbers. So 1 plus 2 is, the first operand is 1. So if we use L1 and square to edit that, plus 2. And then it outputs the result, the answer. So wire the result into some other gadget, like a value slider. So this is giving us 3 because 1 plus 2 is 3. So operand 1 or A is 1 and operand 2 or B is 2. So it's going to add 1 and 1 is 2. But you can actually add lots and lots of numbers, and there's kind of no limit to it really, until you get to like super high values that have to be super precise or something. So if we wire both of these into here, and change the wire blend mode to blend, that's L1 and X to change these, then it's going to average out all of the values coming in through these wires. So the average of 1 and 1 is 1, the average of 1 and 0 is half, things like that. So that would output a half because now it's not adding anything. But then if we multiply this by the number of wires coming in, which is 2, then it will go back to adding because of reasons. So 1 plus 0 is 1, 1 plus 1 is 2, and we have like some others. Then we've got 5 wires coming in, so multiply by 5, and it's getting the right value, and that's like 1 plus 1 plus 1 plus 0.3 is 3.3. That will make sense. So the reason this works is averaging. If you think about what that does, it adds up the values and then it divides by the number of values. So it adds it up to 3.3 and then it divides it by 5 because that's how many values we have. But then if we multiply it by 5 again, then we're back to what it was just added up. So it kind of cancels out that last step of division. So you can have like tons and tons of these values all coming in and it'll still work fine. And you can like multiply, and now it's 1 times 2, subtract, 1 minus 2 is minus 1, divide, and you get a half. It also has comparison operators. That's what these are called, operators. So greater than is A greater than 2? And it's not, so it's going to send an off signal, which is a 0. And if it was true, so like if I did less than, is 1 less than 2? It is, so it's sending a 1. And now you can use that to like power some logic or trigger something or whatever you want to do. And then equal is, are they equal? Is 1 equal to 2? No, so it's sending a 0. If we change this to 2, then it will be sending a, yes, that's true, so it's sending a 1. So gadgets can actually have a higher precision than what is shown here. So usually they can go up to 3 decimal places, but it usually rounds that up so that you only have 2 decimal places shown. So if I go 2.001, and if I use a number displayer instead, you can actually see that. So if you wire A straight into there, that's receiving that full number, and if we give it 3 decimal places, you can see it's actually storing 3 decimal places. Now if we compared that 2.001 to 2, it still says it's true because it's kind of, when it does the operation, it's kind of rounding to 2 decimal places. And this is actually quite useful because in the world of code and processors and computer stuff, it's almost impossible to get a really accurate number, like for like 10 decimal places or something like that. It gets kind of less and less accurate, but it's roughly right. So this allows you to not have to worry about that. you can just compare it to 2 decimal places and it will work fine. Next, we have the remainder after division, which is a bit more interesting. So let's compare 2 different calculators, actually. So this is remainder after division, and this will just divide. So it's not finding the remainder, it's just dividing and giving you the answer. We'll wire that in there. So let's do 23 divided by 5 instead. Okay, so division, 23 divided by 5 is 4 and a bit left over, because 4 times 5 is 20, and then you've got 3 left over. And that's what the remainder after division gives you. Whereas divide just divides it, so it keeps on dividing the 3 by 5, and you get 0.6 tagged on the end. So this lets you find just the bit that won't fit into the division sort of thing. So if we grab that, so we got our remainder after division, and then we subtracted it, get the 23 and subtract that remainder, and then we put that into the division instead. Now we've got 20 divided by 5, and we get 4, which is the complete number. So we don't end up with a decimal place, we just get a perfectly rounded figure that we get after division. Another thing you can do with it is to kind of loop values. So if we went down to 0, then 0 divided by 5 is 0 and nothing remaining, so nothing really comes out. And as you go up, it's sending out the same value. We've got 0.5 to 0.5. And as you go up and up, it's still sending this same value because it still won't go in perfectly to 5. And as you get closer and closer to 5, you get right up to it, and then you tip over to 5. Now it will go in perfectly. It will go in one time with no remainder, so it will send out 0. But now that will go in one time with 0.04 remainder, so it sends that out. So you kind of you can just keep on increasing this, and it will just give you values between 0 and 1, and it will kind of loop around. And if we go down, so if we go down as we reach 5, it'll get lower and lower, and then when we get to 5, it'll loop back round to 4.99 and keep going down from there. So now you're kind of subtracting that remainder from 5, and then you keep going down. And then when you're in negative territory, it kind of, what you'd like it to do is, because we're going negative, you want this to be subtracted from 5. So like 1.09, you want to subtract it from 5, so it's still in that 0 to 5 range. But it doesn't, because what is minus 1.09 divided by 5 is 0 with minus 1.09 left over. So that's what it gives you. So then you keep on going down, and it works the same way, but just flipped with the negative sign. If you wanted to make sure that the negatives still map to that 0 to 5 range, then you want to do something to this first. So I'll just copy this out. It's still got that value in here. We don't need this here. And we want to add 5 to it. So now we're getting 5 minus this number. So we're back in that loop. And if we wire that in there, you can see we're getting that value. And then if we keep going down, it'll go beyond it. So this will only work for between 0 and 5, like minus 0 to minus 5 sort of thing. But we get the kind of value that we're looking for, where it loops around just between 0 and 5 again, like that. So if you want it really airtight, then you can go another step, which is, instead of just adding that, we find the remainder first of this negative number, which again works the same, so it'll loop around between minus 0 and minus 5. So if we get that, we've got our number there. Remainder after division of 5. Then, so what does that give us? That gives us this negative number. And even if we go beyond minus 5, it's still looping round between -0 and -5, if you think about it that way. And then we add 5, and that becomes between 0 and 5 again up here. So that's looping between 0 and 5. So we don't actually need to do anything else after that. We could just wire that into there. But then if it's positive, we need to do that again for this one here. So that's why, so we can kind of do this 3-step thing, loop it for negative, and then add to it to make it positive, loop it for the positive number, and then you always get it looping around 0 to 5 on the output. So that's just like a little trick that you may want to use for various things, various pieces of logic. Next we have minimum. So if we set this to 1 again, minimum. So here it doesn't matter which is which. So for this one and that one and that one, it matters which is which, because 1 divided by 5 is different to 5 divided by 1, for example. For minimum, it doesn't matter which is which. It just forwards out whichever one is the lower number. And if you go to negative numbers, it will send the negative one instead. So like that -2 is lower than the -1, so it's sending out the -2 value. And then maximum is the opposite way around, so it will send out the -1 because that's higher than -2. If you make them positive, it still sends out the 2 because that's higher than the 0.87. Power of is multiplying the same number by itself a number of times. So if we have 10, or if we start at 0, let's set it to the power of, 10 to the power of 0 is always 1. Anything to the power of 0 is always 1. So it kind of starts off, if you think of it as like a chain, you always start off with 1. And that's why 0 means you just start off with 1. And then if you set this to 1, you're multiplying 1 by 10 1 times, so you can get 10. If we set this to 2, then it's 1 times 10 times 10, which is 100. So for tens, this is very easy, but you can do it for like other numbers. So 1 times 2 times 2 is 4. If you go to negative numbers, it's dividing that many times by this number. So it's 1 divided by 2 1 time. So 1 divided by 2 is a half. And then if you go to -2, 1 divided by 2 is a half. Divide that by 2 and you get a quarter. So you get kind of smaller and smaller numbers like that. That's how the powers work. Round down actually ignores the second operand entirely. This slider no longer does anything. It only cares about this. So it rounds down to the nearest integer. So if it's a little bit above, it's still sending out the 2 because that's the nearest integer going down. And that will kind of make sense. And if you go negative numbers, it's still rounding down to the nearest integer. Round means it will round up or round down depending on the closest one. So if you go to a little bit above 0, then it goes down to 0. And if you go a little bit below 1, it will go up to 1. And if it's on 0.5, then it rounds up because that's how maths generally works. And then round up is just rounding up, so it doesn't matter if it's closer to 0 or 1. If it's above 0 and below 1, it will round up to 1. And if when it goes above 1, then it will round up to 2. And same for the negative numbers. And then absolute value doesn't care about the second one either. It just gives you the same value, but it's always going to be positive. So if it's a positive number, nothing really happens. If it's a negative number, it makes it positive and then sends that out. So that's fairly straightforward as well.
Thanks for watching. I hope you learned something interesting. Go to patreon.com/TAPgiles to learn something new every day.